Okay. Integrating other powers of X. This will be a pretty straightforward and easy thing. Go. If I stand in front of that, then you can't read it. If you integrate, what happens? Like, what are you doing to integrate something?
The power goes up by 1 and you divide the whatever power.
Perfect, right? Power goes up by 1 and then you fiddle with the coefficient so that when you derive it, it ends up back to where it goes. Perfect. Cool. What you just said is that. There's one other thing that we've got to tack on, the plus C. Yeah, because we don't know where it came from. If we derive it, the C would disappear, so we just tack that on basically to acknowledge our ignorance. Cool, alright. Nice easy thing. So that's that. I'll write this as capital F of X. You could just as easily have written this if, say, that was Y, just to make it easier. Could have just as easily written it like that. Same thing. I'm just going to write capital F of X just for short. Cool. All right. What do I get?
1/3 X cubed plus A.
Yep. Beautiful. Good job. That's a 3 by the way. Fantastic. Go. Anyone want to tell me the next one?
1 over 8 x to the power A plus C.
Beautiful. Is this difficult? No, right, it's boring and easy, yeah? That's what I wanted today. Cool, okay. I want to do this guy now.
X to the power of half.
Okay, right, so first thing you do is change it out of the root because the root's a pain. Okay, so this is still equal to x to the half. Cool. Now what do you want to do?
Now you want to get add 1 to 1 and a half, and then you get 3 over 2.
Okay, when you, 3 on 2, cool.
And then 3 on 2 divided by
It's 2 on 3.
Is 2 on 3, okay.
And then plus A.
plus C.
I'll see. Cool. Now, is this as straightforward as the other ones? No. Is it really close?
Yeah.
It's really close, but you've got this added annoyance of fractions. How do you know if it's right?
Derive it.
Right, just derive it again. Super quick, cool. 3 by 2 is 6, 2 by 3 is 6, 6, 6, 1, done. Cool.
Oh, well, minus 2 on 2.
From the power, yeah. Power drops by 1. 1 off 3 on 2 is 1 on 2. Right, and the C's going to disappear. Fantastic.
We need to derive it with the square root. Oh, 3 to the half.
All good? Okay. Yeah, particularly when there's this many fractions floating around, I highly recommend. I mean, I tell you to do it all the time anyway, but derive it, just make sure it ends up back where it started. Just because it takes such a short amount of time to check it, it's worth checking. And it's so easy to just turn something upside down or stuff up a negative or something down. You don't want to lose a mark for 3 seconds of checking time. Cool. Somebody else want to give me what we're going to do?
Change it into power.
Cool, what do you get?
Around 5.
And so?
That'd be 5 on 3x. 5 on 3. No, not 5 on 3, sorry.
This is how it is.
Yeah.
Okay, what should you
5
do
on
first,
A.
the front or the back?
Probably do the power.
Do the power first, right?
Yeah,
Cool.
8 on 5.
8 on 5, great. So therefore the coefficient is?
5 on 8. Plus A.
So it's not hard, it's just easy to do it dumb, so always just double check it. Q. Next boy, anyone want to tell me?
Just integrating.
Say again.
Just integrating.
Yeah, just integrating. All of this we're just integrating.
X to the 4 plus A.
Half x. Okay, so you've done multiple steps at once. Okay, cool, that's fine. And you can, if you want to go run, that's fine. Cool. So we have that would go up. We've still got the 2, divide by 4. We can simplify. And we should have plus there on that. Cool. So always
That's all we're
simplify.
doing couple.
Sorry?
What's the difference between that one and like the first one? Oh, never mind.
Nothing. It's the same, it just simplifies out with a fraction. Yeah? Cool. Next guy. Any takers?
10x into a power.
Now, 1 and 2, you guys have already, you're fine. So I'll open up the floor to other players.
You guys are fine.
Yep, so what do you get?
6 x to the power of 5.
5/3, cool. And Dan?
power goes to 8 over 3.
Cool.
The times goes from, oh god, 18 over 8, which simplifies to...
Perfect. So we're doing multiple things, right? So rather than basically asking the fakes to punish us by stuffing up fractions, one thing at a time. 6 times, where am I? Yeah. Cool. Beautiful. 18 on 8. Should have had a plus C. Cool. Divide by 2. Is that it? I think. Done. Cool. There is nothing wrong with using an extra line for calculating. If you can do everything in one line, fantastic. Go nuts. If you can do everything in one line and not always get it right, go back to doing it line by line. Right? There is no point getting a really quick wrong answer, right? Because then you blitz through the thing and you're like, I'm fantastic, and then I give you a mark at the end and you're an idiot. What are you doing? Right? Always go safety, because there's no point in having quick wrong answers. Okay. Next boy.
Bring it up. Bring it up.
What?
I'll connect to Mr.
I didn't know what you said. You just said,
Do
who's
you
it?
want me to?
You can if you want.
You'll see 2x to the power of, I'll just leave it simple.
I don't know what you're saying.
You can divide by x.
Okay, right. So, first thing, is there a problem?
Yeah.
What?
I think that's quotient wrong.
Right, it's quite right. I've got to divide.
Yeah.
Right? Can I do, right now, can I do calculus with divides and things? No. So I've got to fiddle with it so that it doesn't have it. Cool. How are you going to fiddle?
You can divide by x cubed.
Divide by x cubed.
Oh, you can
You can take 2x cubed.
take out x cubed.
Or you can
from
just
top
go
and
6 to the power of negative 7.
bottom. As in, like, you can cancel x cubed. Take out a factor of x cubed.
Okay, you could do, okay, we'll do it that way first and then we'll fiddle with it. Okay, so taking out an x cubed off the top and the bottom
2 minus 4x squared over 6x to the bottom.
to the, oh sorry, to the 4, yeah.
And then you can bring it up to the top. So it would be 6x to the negative 4 times 2 minus 4x squared.
That?
Yeah.
Okay.
You also take out 3.
No, you can also take
You could take out a 2 as well, okay, fine. Maybe don't write this one down.
and then expand it.
Okay, and then expand it.
And then you can grab it.
Okay, now we do 1, 2, 3, 4 lines in. Cool.
Why can't you just go 2x to the power of 3 minus 4 to the power of 5 times 6 to the power of 6x to the power of negative 2?
Right, so that would have jumped us from there to there straight away, so that would have been a better move.
Oh, yeah.
Right? How about this move instead? 2 divided by 6 is
1 over 3.
x to the 3 divided by x to the 7
X to
Negative x to the 4.
minus
X to the
4 over 6.
2 over 3.
This by that,
4 x to the power of 2.
negative 2. Cool, done. One line. That saves us a lot of time. Now, you could do it the other way, that's fine. But obviously, every extra one you've got in there when you're manipulating,
That
there's
would
an extra chance.
that
it's
would
not.
work if it was asking us to derive that equation instead of integrate nearly.
Say that again.
Would that work if that asked us to derive the equation instead of finding that?
Yeah, because we still need it to be in that form rather than that form before we do any calculus.
Because that's the same thing.
This and this are equal. Yeah?
Oh, so
We haven't done it.
integrate. Oh, okay.
Yeah? Go.
Yeah.
Good. Alright, can we integrate that?
Yes.
Yes, okay, because it's nice and flat. Cool. Any takers?
It'd be
Negative 5
3x.
over 3. It's
Negative 3x to the negative 3.
Negative 3x to the negative, that's it?
No, that's for the first one. The first half of it, isn't it?
Okay. This is why you don't do everything in one shot.
Oh, no.
So, we've got
Take
this
the
guy,
three.
what's the power going to turn into?
No, it's not.
negative 5.
Ne-
Negative 3.
Negative 3, right, because we're going up. Cool, okay, so that means I'm going to divide by negative 3. This had 1/3 originally there.
So it's
Oh, don't worry about simplifying yet, we've got to finish the line.
1 over negative.
Right, because that's a common error in exams and everything. People will do this, right, forget about this and go, oh, I'll simplify this, and then they think they're done.
yeah, and then you put negative 3 on the bottom. Is that correct?
Hold on. Oh, sorry, for this one?
Yeah.
Yes, okay, so now you look at this one. Fine, so now I've got minus. Power goes up. What do I get?
Negative 1.
-1.
That's just geometry.
So I've got 2/3 divided by -1. Right, now, do you have to do all of this? No. If you want to do it a slightly different way, go nuts, that's fine. But, safety first, yep.
From here, can you take negative 3 and that negative 1 onto the bottom, make it 3 times, negative 3 times negative 1, which is equal. So it'll be like 1 over 3 x to the power of negative 3 minus 2 over 3 x to the power of negative 1, all over negative 3.
You're playing with good ideas, but your execution was sloppy. This is 1/3 divided by -3. So I've got a positive divided by a negative, so I end up with negative something.
Yeah.
Right? If I have a third divided by 3,
That will give us 1 over 6, negative 6. 1 over negative 9.
negative 1 month, right? Cool, cool.
Yeah.
Alright, this guy hasn't changed. Cool. Next bit,
Positive geometry.
positive, because we've got negative, negative.
Oh, and then 2 and 3.
Cool.
And then you just say 9 and 3 on the bottom.
9 and 3 on the bottom.
So it becomes negative 1 x to the power of negative 3 plus 2 x to the power of negative 1.
Oh, okay, I see what you're doing.
Over.
You have to times the other side by 3.
So you've got options from here on how you might want to manipulate it. You don't necessarily have to manipulate it. But, cool, I'm going to have -1 over 9 to the x 3 plus 2 on 3 to the x. Oh, sorry, times x. Are we happy about that move?
Yeah.
Alright, I just do that to get rid of the negative powers. You don't necessarily have to, but it makes it a bit easier to see what happens. If you desperately wanted to join these up, you could. So we could have 9x cubed plus x. What are we going to do? Negative, wait. Yep. Yes, no, yes, no. No.
I was just 27.
We could, oh, okay, we could do this. Sorry, times by 3. So we get -1 plus 6x squared. So you could do things like that if you desperately wanted to. That doesn't really make it any better though. Yeah. So this is like, that's not required at all. But you should be going from there to there, just because this is easier to deal with. Yeah, that last one is easier to do things with next year and definitely a lot easier in Spesh, but you don't have to, yeah. Cool. Alright, are we happy up until the purple star? We're all happy? Yep, cool. Okay, beautiful. Alright, go on the other side. Got this boy, what you gonna do?
X to the power of negative 2 and then integrate 3.
Beautiful. So there's x to the -2. Oh, one capital anyway. Cool, what do you get, sorry?
Negative x to the power of negative 1.
Negative x to the -1. Yep.
Or negative 1 over x plus c.
Just realised we missed that off all this then. Cool. Beautiful. Everyone's happy?
Why did you plus c?
Why do plus that? Okay. So integration is just anti-differentiation, right? If I was to derive this, what would happen to the C?
It will turn disappear.
Right, it'd disappear, right? If that was a 7, right, what would happen?
It will disappear.
Right. So if I derive it and then integrate it, if I don't have this plus C, I've lost that information about the potential 7. So the plus C just represents there could have been something here. We don't know.
Yeah.
That's it. That's all it's doing. Alright. Cool. Are you taking slides? No. Do a break. Can you rewrite that?
Yes.
-3 times x to the half.
X to the
Negative half.
negative half. There you go. Beautiful. Good job. And so,
The lights. Negative 3 3 over positive half x to the power positive half.
Okay, so power first. This at 1 would become positive half. Alright, we need to divide by that. We had our original list. So,
It would be
negative 3 divided by half, negative 6, yep.
x to the power half plus c.
Right, which is the same as. If you reckon you're okay, have a crack at that. We'll give it like, I don't know, 20 seconds head start or something.
I'm not sure if I should use my new book or use my old book. I've got a new book for maths. I'm not sure if I should use that.
5
or
or
use my
X.
old book.
The 6.
Or is the old book like full or?
It's nearly full.
It's up to you, it's up to you whenever you want the transition to occur. There's only 20 goes up to D, and that's it. So I'd probably finish off 20 and then switch over, because that's the end of it, and then we've got the SAT.
What is the bottom part of the next one?
So this next big one. 4, 5th root, to the 6. How many pages are left in the old one?
Got like, got like 30, 20.
30? Yeah, no, finish that first. That's the size of the chunk there.
But like, my cousin.
They're nicely coloured in.
My nephew kind of.
You can,
I'll see you.
I'd finish off chapter.
Yeah, that's what I thought. I was like, oh, what's
Just
this?
because then you have a nice transition rather than just halfway through a thing. Just
Yeah, no, that's fine.
but it's up to you.
This is when I was talking about building, did you tell them about what building it is? So, you know that it's, you know the root is going to be on the one of the negative, so it's 4. So it'll be, I'm going to be 5. So it'll be 6 over 5. So we're putting it at the top, which is going to be, because I'm at bottom right now, so putting it at the top will be no, you see the fifth root of x is going to 6.
Well, throw was fine, it was the catch was the problem.
Oh, divide by r. No, negative 3 divided by r. You have to keep changing root. So 3 times 2 over 1. Did you?
No, I think you changed flip, changing one.
Ah. Yeah.
I'm just thinking.
Okay, it's normal to you. Happens.
I would have started at 3.
Aaron's okay. Ral's okay. Tyler's okay. Ginger okay. Celestia okay. Yep. Cool. Brian's okay. Yep. You guys are okay?
Yeah.
Yep. Cool. Okay, I think we're alright. Alright, last one. We've got this. Gives us x to the negative 1.
Two ideas if I'm doing
Okay. We do that, we're going to get, this goes up to 1, gives us 0.
That's just x to the negative 1.
Okay?
You integrate that?
So I've got a 1 in front of this, essentially, and then I have to divide by this. What happens?
Yeah. Undefined.
Undefined, apparently.
But
Now, that's not quite true. We'll learn how to deal with that later. But for now, yeah, you stuffed.
isn't it just x to the negative 1?
That's x to the negative 1.
I know, but after you integrate it, it drops the power to, like, isn't x to the negative 1 times x to 0 the same, sorry?
Wait, what?
What? Because x to 0 isn't that just 1?
Yeah, that's 1.
Yeah.
1 times 1 divided by 0.
No, but I'm saying, if you times that by x to the negative 1, you get x to the negative 1 again. So wouldn't your 1 over
1
0...
timesing by x to the negative 1. What?
Um,
Remember, this power has to go up, right?
yeah.
And then you divide by whatever the new power is.
Is that how it goes?
Yeah.
I know it works. No, I know it works, but like,
What do you think?
can I just know how it works now?
Or what does it turn into?
It would have to be x to the negative 1.
Oh.
Because you have to add 1 to the power.
We haven't done that. Hence why it doesn't exist yet for you guys. Actually, you can do it special.
Yeah.
Or you can do the more general where this is the derivative of the underneath and then that's the derivative in there. But anyway. So yeah, for now, if you have something over x to the 1, you're stuffed. You can't touch it. But everything else, every other variation of things you can do. Other things to look out for.
Can't you, can you change the equation and square root that 1 and then square root the x?
Square root the 1 and square root the x. As in, say, that.
Yeah.
That does not equal that.
Uh,
So you, like, I mean, you can, but
Yeah,
then you're
no.
not answering the same question anymore.
so
So
like, you can basically say that all that's squared.
all that squared, but then that would be, this does not equal 1 over x squared.
For what?
I'm not like the square root of x squared. Would that not
Square root of x squared, okay, fine, alright, so we've now got 1 over the square root of x squared, okay, how are you going to integrate it? How do you integrate that? Because you've got a function inside a function.
Oh, okay. And this can you use for quotient?
Yeah, channel.
Got
It doesn't work the same way as integrating, as deriving, sorry. So you've got your chain product quotient for deriving, and that'll work just fine. When you try to apply those sorts of things to integrating, all sorts of new problems turn up.
So is there specific ways for that?
There are ways to deal with it, for the most part, methods doesn't deal with any of them.
Whoa.
It deals with it in speech.
The rest of methods is us contemplating specialists.
You what? I don't know, what'd you say?
Most of methods is us contemplating about specialists.
No, just the natural questions that you'll ask in methods,
Today?
right, very quickly just become more complicated, and then that's the realm of spec.
Oh no, everything that we can't do, like everything that will be undefined methods is basically specialist work.
Commonly, yeah. Commonly, the complicated parts of methods where, yeah.
So when we look at a methods question and say, oh, it's wrong. Specialist
Yeah.
work, like, no, it's not.
Yeah, so if we say like just square root of 1, sorry, that's 1, right?
But,
We do square root of negative 1, in methods you just say, not a real answer, don't care.
Yeah.
But in spec you have to get going.
Double.
very situation.
Yep,
Spec doesn't touch anything undefined, do they? Or does it?
doesn't touch anything.
Isn't like we won't be like, alright, 1 over 0 equals undefined, oh, but it doesn't.
Depends on the context. So
We're
possibly
in the context.
depends on the context. So I can ask you guys that stuff in methods actually.
They're not. I don't know.
What happens as you approach 0?
Every person
Gets closer and closer to.
0.
One.
2, 1.
That's that, yeah? That's as I get closer and closer to x equals 0, what's y doing?
Increasing.
Increasing. So where does it go?
Infinity.
Infinity.
Positive infinity.
Yes, I can believe the dog trunk is.
But if I put 0 in there, what do I get?
0, undefined, sorry.
Undefined, right? So I can still ask, like, the nominal answer to that is undefined, but if I ask it in terms of limits, yeah, you can do that.
Yeah.
Marble.
Ah, so that's what you mean by context.
Yeah, depends what you're asking.
It's like looking at it at another angle, basically.
Cool, this is another thing that gets a bit stuffed. Because you've got a function inside a function, right? You don't. As soon as that happens in methods, unless you can expand it or fiddle with it to make it back to one of the things you can do.
Can't you just expand the bottom and then bring up the top?
So it's in, okay,
So
so
we get 4x.
expand the bottom,
4x squared plus
12x plus 9, okay,
and then bring all of that up as a -1. Oh, but then you've got, yeah.
yeah. You still have that, you have all that and -1, so now you've got a function inside a function, same problem.
And you can't integrate that because you don't have anything from there. But if it was derived, you could.
Say that again.
If it was asking us to derive it, we could.
Yeah, you could derive it because you know how to use chain rule to derive. There's no, well, I'm just going to say, there's no chain rule for integration
In methods.
in methods.
What's the code in integration? Yeah, and special.
You don't,
It doesn't have a name.
you could use U substitutions would be one way of doing it. For this one, yeah, just do U substitution. Oh, actually not needed, you could take out the 2 and then do it as a linear. Yeah, that one you can just do by recognition. But don't worry about it. Like, that's the domain of spec at that point. Yeah, you don't have to. This last column is out of range, out of range. I can't even think of the word I wanted to use.
Out of context.
Out of reach.
Yeah, out of reach,
Out of this world.
Current knowledge.
out of study design. So this is not on the study design for methods. So I'm just putting it there as a warning thing if this ever happens, then stuff's gone. Or you'll have to use the CAS to do it. Q. That's it. We're already easy one. That's 20. Any queries, questions otherwise? Go. Beautiful.
I like this one.
Let's go.
There you go.